Good day, students. Welcome to mathgotserv.com. In this clip, we're going to be taking a look at how to write equations of lines parallel and perpendicular to a given line through a specified point. Okay, so the instructions are: write the equations of the lines parallel and perpendicular to the given line through the given point. So for question number 1, let's say we have the line y equals 1/3 x minus 2, and it's going through the point 3, -2. Okay, so we're going to write the equation of the line parallel and perpendicular to this line right here that goes through this point. So we're going to start with the parallel line, and then we'll do the perpendicular line situation after that. Okay, so to get us started, we're going to start by writing down the line that we're given, y equals 1/3 x minus 2. And then let's think about what we need to generate the equation of a line. Let's specify it on the side here. So we need two ingredients in order to generate the equation of a line. First, you need the slope, m, and then you need a point, x1, y1. Alright, so we just input these two components into the point slope form of the equation of a line, and that will generate the equation that we desire. Alright, so given this line right here, what is the slope of this line? Okay, what is m, the slope? Well, we are going to use the point slope form of the slope intercept form of the equation of a line, y equals mx plus b, to determine what the slope is. Okay, so what you need to remember is that the coefficient of x, or m, that's the slope. All right, so we can see what the coefficient of x is here, which is 1/3. So the slope is 1/3. All right. Now, how does the slope of this line relate to a line that's parallel to it? Well, this is a connection here. If two lines are parallel, then their slopes are the same. So the slope of a parallel line, let's write it m sub parallel, is going to have the same slope as the original line. Okay, so the original line has a slope of 1/3. The slope of the parallel line is going to be 1/3 also. Okay, so we have one ingredient down, the slope. Now we need a point. So the point that the original line goes through is what we're going to be using. So the point is 3, -2. And that helps us to see that x1 is 3, and then y1 is -2. So now that we have all the ingredients that we want, we are now going to put it into the point slope form of the equation of a line. Y minus y1 equals m times x minus x1. We're going to be using m parallel in this particular formula. All right, so let's go ahead and substitute the components. So we have y minus y1, y1 is -2, is equal to m parallel, slope of the parallel line, which is 1/3. It's the same as the original slope, times x minus x1, which is 3. Simplify the left side a little bit. Combining these two signs, we're going to have y plus 2 is equal to 1/3 times x minus 3. Ladies and gentlemen, this represents the point slope form of the equation of the parallel line. Alright, so let's specify what form this is. This is a point slope form of a line parallel to the original line and goes through the point 3, -2. Let's go ahead and also create the slope intercept form. So in order to get the slope intercept form, all we just have to do is isolate y. Okay, simplify and isolate y. So we're going to do that by distributing 1/3 across these two terms right here to get rid of that parenthesis. When we carry out that distribution, we're going to have y plus 2 is equal to 1/3 x minus 1/3 times 3. All right, and we'll simplify that. We'll have y plus 2 is equal to 1/3 x And then you can divide this out. 3 goes here, 1, 3 goes here, 1, minus 1. And then the final step to isolate y is you subtract 2 from both sides of the equation. And then you get your final result. You have y, this is y parallel, is equal to 1/3 x minus 1 minus 2. Signs are the same. You add and keep the sign, minus 3. All right, so this is the equation of the line parallel to the given line through the given points in slope intercept form. Slope intercept form. All right, so now that we have the parallel line, let's go ahead and determine the equation of the perpendicular line. All right, it's going to be the same procedure. The only thing that we're going to change is basically the slope. All right, so we have the perpendicular lines case, perpendicular. Okay, so let's start by writing down the equation of the line that we're given, just like we did in the parallel situation. So we have y is equal to 1/3 x minus 2. All right, so we know what the slope is here. If we put y equals mx plus b, remember that the slope of a line in slope intercept form is the coefficient of x. Okay, so the coefficient of x is 1/3. All right, so now here is where it's different. We need to find m perpendicular. What is the slope of two lines that are perpendicular to each other? If two lines are perpendicular, the slope of one is a negative reciprocal of the other. If they're parallel, they're the same. Okay, but if they're perpendicular, the slope of one is a negative reciprocal of the other. Okay, so if m, the slope of the original line, is 1/3, then m perpendicular, the slope of the perpendicular line, you flip the sign, negative, and flip the number 3. Okay, so it's going to be -3. And then the point is the same point that it's going through, which is 3, -2. So that helps us to see that x1 is 3 and y1 is -2. Okay, so now we have all the things that we need. Remember the two things that we need that we talked about, just a slope and a point. So we have a slope and a point. So we're going to plug them all into the equation. Y minus y1 equals mx minus x1. In this case, we're looking at m perpendicular, right? So let's substitute. We're going to have y minus y1, which is -2, equals m. M in this case is -3, right? So m x minus x1, which is 3. All right, multiply these two signs on the right here. We're going to have y plus 2 is equal to -3 times x minus 3. All right, ladies and gentlemen, this is equation of the perpendicular line in point slope form. All right, so point slope form. And then let's also write it in slope intercept form. To achieve that, we just isolate y. Simplify and isolate y. So we're going to take -3 and distribute it across x and -3. When we do that, we're going to have y plus 2 is equal to -3x. Minus 3 times -3 is +9 plus 9. And then to finish this off, we're going to go ahead and subtract 2 from both sides of the equation, like that. And then that's going to give us y equals -3x plus 7. Okay, so this right here is the slope intercept form. Slope intercept form. Okay, so what we're going to do now is we're going to go ahead and graph all three just to help you see visually what parallel and perpendicular lines look like. All right, so let's look at the graphs. We're going to color code them, okay, so you can see the difference. So let's start with y original. So the original one, the given problem, let's call it y original. That's 1/3 x minus 2. So to graph, we need the slope and the y-intercept. Okay, so in this particular case, the slope m is the coefficient of x. So m is going to be 1/3. Okay, these are going to be your directions or your movements. You're going to move 1 unit up, that's your rise, and run 3 units. You're going to start or begin at the y-intercept, -2, which is 0, -2. Okay, so let's go ahead and graph that line. Set up our coordinate system, our y-axis and x-axis. So we're going to graph -2, 0 is our starting point. So 0, -2 right there. And then we're going to rise 1 and run 3. 1, 2, 3. Bam, right there. Okay, we can do it again. Rise 1, run 1, 2, 3. So that's the first line. That's the original line. Okay, so let's go ahead and sketch that in blue, y original. So what this problem is asking us to find is our 2 lines, okay? One that is parallel to this line and another that's perpendicular to this line. But the condition is they have to go through the specified point, namely 3, -2. So let's keep those points in mind. All right, so this is the first line, the original one. So now what we're going to do is draw the other 2 lines. So let's also label it so we know what we're doing. So this is the original line, y sub 0, which is 1/3 x minus 2. Okay, so the next one, let's put it in green, is the y parallel. The y parallel that we got in slope intercept form is 1/3 x minus 3. All right, the slope here is 1/3. So we're going to do the same movements as the first one, rise 1, run 3. And then your y-intercept is -3, so we're starting at 0, -3. Okay, so let's graph it. So 0, -3 is right here. 0, -3, rise 1, run 3, 1, 2, 3. Rise 1, run 3, 1, 2, 3. Right there, bam, bam. Let's go ahead and graph the line through the given points. So we're gonna make it green. So there you have it right there. So if you think about it, what are parallel lines? Parallel lines are basically lines on the same plane that have the same slope. Okay, they have exactly the same slope. And if you take a look at these 2 lines, you can clearly see that they're parallel lines. They don't intersect, and they have the same slope, namely 1/3. All right, so this one that we just drew is y parallel, which is 1/3 x minus 3. And does it go through the point that we want? The point we want is 3, -2, right? So 1, 2, 3, 1, 2. This is the desired point right here. Okay, so don't forget it. That point, that's the point that it has to go through. So it has to go through point 3, -2. This one does, so that's good. So we need one more, which is y perpendicular. So y perpendicular is, what did we get? We got -3x plus 7. So for this one, the slope is -3. Write it as a fraction with the invisible denominator 1. So we're going to fall 3 and run 1. Where do we start at? We begin at the b, y-intercept, 0, 7. Okay, so let's go. 1, 2, 3, 4, 5, 6, 7. Right there. Count again. 1, 2, 3, 4, 5, 6, 7. And then we're going to rise, we're going to fall 3, okay? Or rise -3, 1, 2, 3, and run 1. Bam. Okay, let's do it again. 1, 2, 3, run 1. Can do it again. 1, 2, 3, and run 1. Bullseye. So let's go ahead and draw the line of the perpendicular. Okay, remember, two lines are perpendicular if they intersect at what? If they intersect at 90 degrees. Okay, and we can see what that looks like right here. This is why perpendicular is perpendicular, because it intersects the other two lines at 90 degrees, and it goes to that desired point. So let's mark it up. This line that we have right here, this is the y perpendicular, and it's -3x plus 7. Okay, so if we mark it using our geometry skills, this is 90 degrees, is perpendicular to that and the original. And then since these two lines are parallel, we can just put arrows here to show that they're parallel to each other. Okay, so in the parallel lines never intersect, they have the same slope. So we can clearly see that our answers are correct. Thanks so much for taking the time to watch this presentation. Really appreciate it. Don't forget to support our channel by liking and subscribing, and also commenting on this tutorial. Tons of support resources can be found on mathgotserv.com. Do check it out. Thanks again for watching. We'll see you in the next video. Goodbye.